Hello and welcome back to Programming with Adam. So today we will be continue to looking at LeetCode. So the problems I'm looking at are, let's see what's going on here. There they are. So are currently the easy ones. So we have done the first three and now we're looking at number 4. So that random to integer and so basically rewrite a Roman into an integer. So let's just start with that. So I kind of just wrote a small intro here. So so if we have an example VII, so what will you do? So you do a for loop. So maybe first for I0, then you have the total is V, which is 5, and then I is 1, then X of I is I, maybe something like total is initially 0. So n of I, that will be V, and then total will be total plus, and we have some sort of table where we can find them. So table, and we will put in a V, which is then should be 0 plus 5 equals to 5, something like that. And n equal to 1, then we will have an I, and total would be total plus table of I, which is then 5 plus 1 is 6, and then we do that again. For I is being 2, total plus I. Okay, so just notice here what we will need. Yeah, the table of this, table of that value, and table of that value. So let's just write that. But maybe actually we will already put the first number into the total. So let's just write. We will start with first entry. We will lock in the first entry to be 5, and then we will start looping from 1. Okay, so it will be something like this. So total is a table of x of 0. First need a table, right? So that would be all of these. So I should be 1, comma, 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 and I should probably like this. Okay. Then we for I in range 1, comma, length of x. What we simply do is we take total and we add it to total plus table of n. It's not n, it's x. 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 And x. Is it called x? Yeah. Actually, wait a second, it's called s. So let's call it s. S table of s of I. And then return total. Okay. So let's just run that and see how far we got. Okay, so we definitely have to do it a little bit nicer. Remove all of the unnecessary. Like that, that, and that. Okay. Okay, what about now? For range, for in. 12, right? So we actually do get a 12 as expected. Okay. So far so good. And now the problem is if we were dealing with something like so like 4, right? If we run that, we get 6. So let's just break it down. So for 6, for 4, we first have that the total is 1. And then for I equals 2. And then we have the for loop. So that will total, the next one would be 5, right? So the total would be 6. And here, we need to make an adjustment. So make just. So basically, we want to get 6 converted to 4. So what we do is, and that is because the entry of x of I minus 1 is, which is x of 0, is that is I, but because the value of it, right? The value of that entry is 1, and usually these things should be getting smaller and smaller, right? This one is actually smaller than the table value of xi, which is x1, which is 5. And if that's the case, then we simply have to adjust. So the adjustment is really we should not have added. We should not have added the 1, but subtracted it. So not 1 plus 5, but 5 minus 1. Or that could also be 1 plus 5 minus 1 minus 1, right? So that's basically what we'll be doing, right? So if table is strictly less than table I, then take the total and subtract total minus 2 times the previous version minus 1. So that will be the idea, and let's just adjust that. So for I, add total, and then if if 5 is strictly less, there we have it, then total needs to be adjusted minus 2 times total minus 1. Okay, so this is exactly what will happen. So let's try to run that. X is not defined. Should have been an S, should have been an S. So everywhere should have been an S. An S. Total table. It's a 0 here. S. 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 Let's just run one more example. So we have ix. No, let's try this one. That'll be 50. No, 58. That's just the easy one. So they're all easy. They're all the same difficulty. So we could do something like 44. L V and then let's take M. Okay, so this is first example. So total is initially M, which is 1000, and then for I equals to 1, we have total becomes total plus table of S of I, which is 1000 plus, so that S, the first entry, SI is V, so this bit is B, so a table of V which is, and V in the table gives you 5, so that would be 1000 plus 5, and then the next thing we'll be having for 2 total is YL, which is 1005 plus 50, and then there is the adjust minus the previous one, which was, maybe there was a point of actually calling the previous one something. So previous, here that would be table of SI minus 1. Minus 1. So the previous one was the 1000. The current one, f of v is 5. Just 5, and then the total for I equals to 1. Total is simply total plus current which is 5. Which is 1000 plus 5, and then 5 over 2. Same thing. The previous is 5. Current is 1000. No, current is position is L. That's 50. So we have total plus like this, and then 5 and current. And then we have to minus 5 as current, which is 50, is larger than previous. So that will be 1045. Okay. So maybe let's just try to run it. See how it runs on this example. So it doesn't give 45, does it? The previous is smaller than current. There's an S missing. Like that. 10. Right. Total. Total. When I is 2. So if we just delete, that should, why are we getting only 10? VL. L should be 50. L is, oh, there it is. There is the mistake. So now we have 55, but if we make the adjustment, 45. Okay, but I wanted to make a current and a previous, so because it just makes it a little more readable. So current is table SI and previous is table AS SI minus 1. So total plus current, and if the current is bigger than the previous, then we make an adjustment. Previous. Okay. So let's just run that again. 45. Okay. So I think I'm pretty happy with that. Let's just run this one. So that should be 1994. Okay, cool. So let me take that thing and put it in here. So definition table. Blah, blah, blah. Okay, turn it over. Run code. Let's see. Okay, and submit. Okay, so I didn't really get the best time as I wanted, so I was just thinking there is a small adjustment. So I guess you're calling these things twice, so maybe we could do previous outside, like that, and just db table 0 as well, and then not make a call in the table, but run this here. So then the previous becomes, so the current, the next current becomes the previous. No, the previous can be used as the current, right? So we can use it for later. Okay, so let me just run that as well. 94 and a few others tests. So 4 and okay, looks okay. So we're just adding this extra line here, and then we're deleting the previous. And then also we could, and then the previous equals to current. Okay. I guess there is another small optimization. Oh, let's run that. So submit. Submit. Okay, so just doesn't seem like I'm getting the fastest possible. So maybe I'm wondering if the current should be outside of the loops. I could set that to be 0, and then I could basically adjust. I could even start at I couldn't start that be 0 and run from 0. Right, and the first iteration will set the. Okay, so that's a little bit of a change. Just test that. For return to. Oh, did nice. I skipped that bit. So return total. Let's just run that. So to have 4 and the description. Okay, we still have that. So that does seem to current. Work as well. Maybe it is a little bit faster because the variables are outside. Let's try to run that. Okay, so I just noticed that there might be another thing. So because the operations are happening, so you could put that saying like if previous equals the current, and then you could make an else here like that. So else, if you're not doing anything at all, then previous customer, then that minus 2. No, like that. So there would be plus current and minus. So instead of splitting it up, it does it in one go. Okay, again a little bit different than before. Let's just run it and see. It seems to be working still. Submit. Okay, so this one did run fast. So we are finally getting one that is 99% better than others. And I'm so it does look like moving these outside helped a little bit, but maybe mostly that we didn't have to do the total equal to twice in each iteration. That could have boosted it up in speed. Anyway, I'm pretty happy with that. So I will leave it with that.